Good afternoon, everyone. I'd like to welcome everyone who has taken out their valuable time to attend today's webinar on optimal blisters or toolings to increase the efficiency of packaging lines. Myself, Seema Soni, and I'm the head of customer support at Inos Technologies. And we have with us Mr. Andrew Renix, who's a technical services consultant at Prodaico in Ireland. I would also request everyone to post their questions in the chat box below during the session, and we'll get back to you with the answers shortly. So, without much further ado, over to you, Andrew. Andrew, you're on mute.
Sorry, good afternoon, everybody. Not a great start. Can you hear me now? Okay, Seema?
Yes, yes, Andrew.
Okay, thank you. Well, hello, everybody. My name is Andrew Renix, and I work in Prodaico. So I appreciate everybody taking the time to join this webinar virtually. If at all possible, I prefer the webinar to be interactive if possible. So if there's questions that come up throughout the slides, I'm more than happy to answer any questions, or we can wait to the end of the presentation as well, whatever suits you. So the two teams that I'm going to present today are basically optimized feeding solutions and optimized blister design solutions in order to try and increase the efficiency of the packaging lines. So maybe just to give you a little bit of information about Prodaico, I'm not sure if people on the call are aware about Prodaico, but maybe just to give you some basic background to the company and to the business. So the company this year, well, maybe, sorry, I should start with myself. So I've been in the business for nearly 20 years. I've worked in the quality department. I've worked in the customer service department. I've worked in sales. I've been lucky enough to travel around the world. I've worked in operations and running the business, and today I'm a consultant into the business. So this year, Prodaico is 60 years old as a business. At the moment, there's about 260 colleagues in the business, and we're looking to try and scale that to about 300 colleagues this year. The Prodaico business, Prodaico stands for Progressive Die Company, and the business started in the early days by making press tooling, specialized in press tooling for local Irish businesses, and then started to specialize in press tooling for Dell, Apple in the computer industry, basically. And how we started in terms of making blister tools, well, we started with a bit of luck, to be honest. We started about 18 years ago. A local Irish pharmaceutical company came to us, and they were looking for some tooling, some forming and sealing tools. They went to the original equipment manufacturer, the machine producer, and it was going to take 4 to 5 weeks to get the tooling, but they needed them in a week. And they knew we had the technology in Prodaico, the CNC equipment, and they knew that we had the design capability. And they asked us to reproduce the tooling. So we reproduced the tooling in about 1 week's time. And then we started to look for what is this blister, what are blister packaging machines, which companies are using them. So we started in Ireland, started to sell to companies in Ireland. Then we went to the UK. Then we traveled throughout Europe. Then we went to North America. And we've continued to travel with it. Basically, that today we're 98% export. So everything gets designed and manufactured and tested in Dublin, and it's exported globally. So we're the largest independent producer of format size parts. The main competitors we compete with are obviously the OEMs, but the original equipment manufacturers. But in each country that we go to, there's also local competitors for format tooling that we would compete against, whether it's the UK, North America, South America, India, China, whichever country. Basically, there's competitors at the OEMs and local competitors as well. How we try to differentiate ourselves is in Prodaico, we've got now 26 blister packaging machines. So we operate out of 3 facilities now. We've 2 production centers in the same industrial zone, and we've also got an FAT test center where we do all the testing of the formats we produce and the feeders that we produce. So we have a range of Ullman, EMA, Marquezini, Romaco, and Mediseal blister lines for testing and validating the tooling. And just some simple images just to show you what we do, basically, the formats we produce. So we produce for the newest of machines, for machines that will still be in the OEMs being produced, to the older blister lines and models of equipment. So we produce for the European blister packaging machines. So that's our core competency. So for the likes producing formats for Ullman, EMA machines, Romaco, Mediseal, Marquezini machines. So I'm not sure if you can see my mouse, but we're a small country, Ireland, in Europe, basically, in Western Europe. And we've got a sales and commissioning engineer presence basically globally, around the world, basically, because we're 98% export. And how we try to differentiate ourselves is, so the tech lab facility that we have that I mentioned has got a lot of European blister packaging machines. So we've laid it out like a blister packaging hall. So a lot of inward visits for customer FATs. A lot of them have been virtually over the last couple of years, but for the last 5-6 months, we've started to see inward customer visits again to Prodiko, which is nice to see. So a large range of blister packaging lines in our facility. So it gives us the ability to be able to test and validate all the formats before they leave Prodiko. We've also got Feeder Lab, which I'll discuss a bit later, but this is the testing center where we test all the feeder systems that we produce. And we've also got an R&D solutions center. So a lot of companies are coming to us with different types of challenges, whether it's new innovations on packaging materials or specialized feeder systems, automation projects, updating cartoners for booklet feeders, tablet lift systems, and maybe I'll present a couple towards the end, just to give you a flavor of what we are doing. So in terms of product feeding
And
solutions, so
hello, Andrew. Sorry to interrupt, but we cannot see your screen.
oh, sorry, excuse me, just one moment. It was, can you see it now? Sorry, Seema?
Yes, now we can see it. Yeah.
Okay, sorry, apologies for that. Okay, so I'll just skip to the next slide. So in terms of product feeding solutions, okay, so in Prodiko, we would make approximately about 800 feeder systems, I think, last year, basically. So what we tend to see is that usually the bottlenecks at the packaging machines usually come to a couple of key items. One can be the cartoner, depending on the stack height and depending on the type of cartoner. On the actual blister packaging line itself, just the blister line, typically the main bottleneck that we will see is the tablet feeding system and how quickly you can get the tablet into the cavity, basically. And a lot of different design practices around how to handle different types of geometry sizes, tablet thickness tolerances, tablet hardness issues, and how best to optimize the feeding solution. So one of the key advantages for Prodiko is that I see is because we get to make for the different OEMs, like for EMA, Ullman, Marquezini, each of the different OEMs handles tablets in a slightly different way, or feeding solutions in a slightly different way. The benefit for Prodiko is we get to see all the different solutions from the OEMs because we're diagnostic to any provider. And it gives us a lot of intellectual intelligence, basically, around how to handle tablet shapes. And then we've got our own platform as well, our own database, basically, of how we optimize feeder systems. So it's one of the core competencies of Prodiko's how to maximize the output of the different feeder systems. And it's a challenge that we typically take on when we go to the market. If there's any companies that are currently experiencing issues with feeder systems, we like to take on these challenges and see if we can offer something that's very innovative in order to increase the speed. So, like I mentioned, we make kind of like tube style feeding systems. So you might know them as Ullman Simtap feeders, or in North America, Aylward style systems, or also Cypro HMH, which is a brand from Switzerland which we represent. These types of tube style feeding systems. Um, on the bottom image here, it's a universal feeding system. So I'm sure you're very well brushbox feeder, universal feeder system. It's capable of feeding certain tablet shapes and sizes depending on the packaging materials. And over on the right, it's the kind of like the vibratory vertical feeder feeding system that's equipped on a lot of the different packaging lines. And this one is for thermoform solution. And with the drum, it can be, if there's a drum at the bottom, it can be for alu feeding solutions. So there's a large database
Andrew?
in Perdite. Sorry.
Hello. Sorry, Andrew, sorry to interrupt. Can you go a bit slower?
Yes. Sorry.
Okay.
Sorry.
Thank
The
you.
Irish talk too quickly. Sorry.
Yes, thank you.
Sorry. So one of the types of innovative feeder solutions that we've produced for the last number of years, it's a challenge that we see around tablet thickness tolerance, and there at times the tablets will come in out of specification that we receive, or in some instances the tablet tolerance on a tablet can be at times plus or minus, I would say, that 0.6. So sometimes you can have 1 millimeter from the maximum to the minimum, or at times maybe on the rare occasion a little bit more than that. And in these types of scenarios, depending on the tablet shape, so for example, if it's round biconvex or if it's an oval shaped tablet, with these types of, from a maximum thickness to a minimum, with this type of tolerance range, it can lead to issues where the tablets can get stuck or lock, cross lock maybe in the vertical, either in the quadrant or the bowl. This is a quadrant selector, but it can be a bowl if it's a Romaco machine. Can lock, and they can lock in the feeder system as well. So, and then it comes to, at times you may need two feeders to cover a certain tablet range, to cover the complete tablet range. So we've come up with an innovation where we can make the vertical feeder out of two segments. Basically, they're machined separately, and what you have here is a dial gauge. And basically, what happens is that the tracks will move within the feeder system to either make them wider or narrower, depending on the actual tablet thickness that you're running at the time. So just dial gauge to let the operator know exactly the position of the feeder once they measure the tablets. Um, that's one solution that we do, and this is just another image basically showing that the tracks will move over depending on depending on the thickness of the tablet, and you just adjust it on this dial gauge. So it can be a good solution on some feeder systems, and for some tablet shapes and sizes that maybe you experience a challenge with the tablet thickness range. Another type of solution that we see commonly, and one that we supply commonly now, is what we call like a piano finger feeder. So with piano fingers at the bottom of the feeder, for, again, this solution is for kind of like oblong tablets or oval tablets. And with this solution, it basically allows, so sometimes you can have a situation with oblong tablets of what I would call the tablet being lazy, coming down the vertical chute, and it doesn't enter the cavity at, you want the tablet to enter at the exact front of the cavity is the ideal scenario. But sometimes these tablets at times can be a bit lazy coming down. So with the piano finger here, it's on a spring-loaded finger. It gives a lot more forgiveness. So if the tablet doesn't come out immediately and hit the front of the pocket, it lets the tablet enter the pocket, and the finger will raise, and it will also help guide the tablet into the pocket. If you have the solution where you have got this issue on your packaging machine and you don't have a spring loaded finger like this, or what I would call a piano finger, the situation you will have is you will get tablets that will break and then start to stack up in the back of the feeder. because the tablets won't hit the front of the pocket. And next thing, the next tablet is trying to come in and enter the cavity, but it can't enter basically. So then it damages the web as well. So this can be a solution for oblong tablets in order to allow a lot more forgiveness basically into the to allow the tablet into the cavity. Um, it's a good solution, and there's just another close-up image of it. So it's a solution we would supply to a lot of PVC, PVDC, and Aclar formats for an oblong tablet, basically. And some more, so the tube style feeding system. So this is a feeding system like the Ullman Simtop feeder or else the Cypro feeding solution. So this is a tube style feeding system. So it's a specialized feeding system. If you have challenges, very difficult challenges with tablet shapes, if you have very difficult challenges in terms of trying to maximize the output speed of a machine, this type of tube style feeding system can be a very good solution, and because you can feed a large number of packs in the index basically over one index. So if the feeder machine is running at, for example, if the forming cycle on the blister machine is running at, for example, um, 60 strokes, 60 forming strokes, or 50 forming strokes per minute, the the tube style feeding system, if it's continuous motion or intermittent, can run at half of that speed basically. Um, and this solution from HMH it's a fully servo controlled feeder system basically. So all the parameters are stored within the recipe. And there's toolless changeover, and there's no need to make any adjustments. All the adjustments, including the level of vibration or the stopper pin positions, can be done online on the HMI. Maybe just to show you couple of videos of this solution. Um, Sorry, I know you can't see that. Just one moment. Sorry. Try and play this again. Seema, can you see the video? Can you?
Yes, yes, Andrew.
Okay, so this is on a continuous rotary machine. So this is on a Mediseal machine basically. So it can do continuous motion, and it also can do intermittent motion. So this is feeding two form indexes at any one time with this model. And again, it can maximize the feeder output speed for this format. And there's also you can also the same solution is available, like similar for Ullman Simtop feeder, and this solution is showing it feeding two color tablets basically in the one blister. And then in terms of some others, so we've supplied like a lot of different types of feeder solutions. So like I mentioned last year, we made over 800 tablet feeding solutions. So we've a large data bank of tablet shapes, sizes, tolerances, radiuses, and it's all linked to the previous designs of how we fed them. So typically when we get a new project in, one of the first things we do is, if there's a feeding system, is that we reference the database that we have. So the database that we have is over 10,000 tablets, and that's for animal health products, which can be extremely challenging from a tablet hardness perspective, to every type of product I think we've seen. So we typically like to get the challenges. If the original equipment manufacturer has failed with a feeder, or the feeder's not running at the right speed, or there's any types of challenges with feeder systems, we're confident once we review it, and we're confident that we can potentially increase the speed, increase the efficiency of the feeder system. And it's like I mentioned, one of the core skills that we have in the company. And we have like a team. The only team that we have in Prodico that I would call like in a cell type environment is the feeding team. So in the feeding team, there's 25 employees and they work in a cell. So the design team that create the designs are working in the same room as where we test and validate the feeders, just that they work next door to them. And also we've machining centers set up. So there's kind of a dedicated cell to feeding technology in Prodico. And the reason we do it that way is because the learning is so important. The learning that we have as a team, and that the team is up to date on the latest innovations. So in terms of tablet solutions as well, we had another challenge. So we had a company come to us that were experiencing issues with broken tablets. Well, they two issues. They broken tablets and they twins or clumps, tablets stuck together. And this issue they were experiencing online in a feeder system, and it was every time a broken tablet, or in a high percentage of occasions when a broken tablet would arrive into the feeder system would stop, and the operator would have to take off the covers off the feeder system, remove the broken tablet, and reset up the feeder, put the cover back on, and get the machine running again. So they asked us, could we come up with a solution like a conveyor system, either online or offline, to remove the broken tablets, so only good tablets were entering the feeder system. So the scope of the project basically was try to get to increase the uptime, the runtime of the packaging line, and reduce the number of micro stoppages. So we've come up with this solution. It's a vibratory mechanical sorting system, to remove the broken tablets or remove twins or to remove clumps. And what we do is we have very special designs as sieves to remove a very high percentage of the broken tablets. And the solution that you see on the left-hand side is an offline system. So it sorts it offline and fills up. In this situation, it's filling up bins, but it can fill up all different types of solutions we provided. And this solution in the middle, it's an online system. So the scope of this project is that we would remove the existing conveyor on the machine. So the existing conveyors, there's a lot of challenges with the existing conveyors on the machines. So some of the challenge, the sorting is minimal to none in terms of sorting. And with the Prodico system, it scans all the tablets. So it's one layer, and every tablet goes across the sieve basically. So it gives a much higher level of rejection. And then with some of the special designs that we do on the plates, it helps us to remove a very high percentage of the broken tablets basically. And the system on the right is just an image of on the back side of the middle basically.
So, Andrew, we have some questions. So, can I interrupt right now?
Yeah, please do.
Yeah. So, there's one question from Orbindo that do you have any solution for feeding tablets with extremely low hardness, that is below 3 kp?
Yeah, so I think we've done some at that level that we've done for some of the animal health products that we handle. They're on like European blistering machines, so it's very similar. The feeding solutions are the same, to be honest, but we've come up with some very innovative feeding solutions for animal health products, and then we had to replicate this type of design for some normal pharmaceutical products, I call them, for human healthcare. So we've got different types of solutions around this. So I think the best way to do this would be maybe to we can send on some images at a later date, because I won't be able to access them now, to be honest, but I can access the information and the designs of how we've handled very soft tablets. And a lot of times with the soft tablets, we also have to put on a sorting system like the sorting system you see on the screen. So this will remove any broken tablets that are arriving to the packaging line in the bulk. So the first thing we try to do is sort them here, and then we'll come up with some very innovative feeder systems to try and handle the tablets very sensitively. So when they're in the feeder system, Um, Basically, they're not breaking in the feeder system and they're arriving in the cavity in good order, basically. So yeah, the answer is yes. We've handled some very, very soft tablets, and we've different types of solutions for doing it.
Okay, Andrew, great. So, Prasad sir, we'll get back to you after today's session and we'll share the images that Andrew is mentioning, and maybe we can further discuss and have a one-to-one meeting. Yeah. So, coming to the next question, we have a question from Milind sir, that what is the highest speed from the format part for the Cipro feeder?
Um, there's no blister machine that can run quicker than the Cypro feeder at the moment.
Okay, great. Okay,
It yeah, it can do like 18 to 20 meters of web speed per minute.
okay.
Like yeah, it's on the highest speed Ullman machines, the highest speed EMA machines. It's there's because you're feeding over the index. You're not feeding one form index. You can feed over multiple indexes basically. So it doesn't have to run at the same speed as the form index. So the forming tool will go up and down and form one index at a time basically. So if there's, for example, just say in the forming tool, there's 2 packs across the web and three in the index for 6 packs in total. When that goes to the feeder solution, it can be 12 or 18 packs in the index. So it can run at half the speed of the forming tool, or it can run even at a third of the speed. It never has to run at 100% of the speed. So it will not be the bottleneck. The bottleneck in that situation will be how quick you can form the blisters on the blister machine for that scenario.
Okay, understood. Yeah. I hope, sir, that answers your question. So, coming to the next question, Andrew, do you have any solution for uncoated tablet with low hardness and deep break line?
Yes, so we've done a lot of these different types of solutions. So solutions such as it depends on the packaging machine. So on the tube feeder, which is more kind of specialized, some very specialized dust extraction systems in all aspects of the feeder. So from the hopper to the tubes to the fill tubes. In terms of the brake line, I think when the brake line is mentioned, maybe it also is leading to broken tablets. I would think maybe the tablets are potentially breaking on the brake line, and you've got that plus a dust issue. So in that type of scenario, it's you need the feeder system to be very sensitive to handling the tablet. So again, potentially something like a sorting needs to be reviewed at the bulk needs to be sorted either with a sorting system, potentially if there's broken tablets arriving in the bulk to the packaging machine. And then you need to have dedusting or dust removal in the conveyor. So in the bulk hopper conveyor, you need to have it and dust removal extraction in the bowl or the quadrant, and also in the vertical chute, and remove the dust, basically, and take out the broke if there is broken tablets. But I presume when the brake line is mentioned, potentially they're breaking on the brake line as well.
Yeah.
So yeah, we would have solutions around dust extraction as well. Okay, I can send them as well later. How we would handle dusty tablets, uncoated dusty tablets.
Right. So, Veera sir, we'll get back to you after this session, and we'll share all the maybe some case studies with you so that you can get an idea of how we can provide a appropriate solution. So, coming to the next question, do you have any solutions to avoid sticking at forming plates, especially in the case of PVDC films?
Yeah, so it's a common enough issue that we're aware of. Yes, so the first thing is how well is the form tool designed? What are the radiuses on the pocket? What's the draft angles on the pocket? Then you need to understand what are the what material are you running? What's the setup that you're running for that material? Optimize the design of the blister, optimize the design of the pocket on the forming tool, and then also in terms of the coating that's applied to the forming tools is very important and can help a lot. So we would apply a very special coating to PVDC tools. So when we're supplying a format that is PVDC materials, we supply a very specialized coating solution. So it's a coating solution that we actually came across when we're doing a project for a Japanese customer. And when we went to Japan, we asked them what is this coating? We saw it on a forming tool and on a feeding system, and they provided us with some feedback around some challenges that they were having with PVDC, and we had never seen this type of coating before. So we did some test projects with them, and we this is what we coat our tools now for PVDC. So yeah, we have some good information around how to handle sticking PVDC, how to remove this as an issue.
Okay, understood. Coming to the next question, can you deliver retrofit feeding system, that is change part is from other vendor and feeding system is from Prodico?
Yes, we can. Yes.
Okay, great.
So yeah, so thinking that yeah, so in that type of scenario, yeah. So a lot of companies would come to us, or we would take on a lot of challenges. One way we start with a lot of companies is that we ask them after we present, we ask them what challenges do you have at the moment, and typically, if they do have a challenge, typically in terms of the format size parts, it's usually around feeding. Either they're not particularly happy with a current feeder system, or they believe that a feeding system can run at a higher capacity, and that we will get challenged about, okay, here's the tablet, here's the blister drawing, the current feeder speed currently runs at, for example, say 200 blisters per minute. We want it to run at 300. The challenge is we want it to run at 300. Is it possible for the feeder system to run at 300 blisters per minute? So we'll just basically ask for some basic information. We'll ask for the tablet drawing, the tablet hardness, the blister drawing, um, the current speed. We'll ask what the current speed is, and then we'll ask what is the expectation, or what is your wish to get the current the existing feeder to. And then once we have that information, I would say within 2 days, we'll have it reviewed. We'll check our database, we'll talk to the feeder team, and we'll go back with a proposal if we can increase the feeder speed. And if we can, we'll supply a feeder system, basically, that will work at the speed that's required. So you can keep all the existing format tools and just change the feeder system.
Okay,
That
great, Andrew.
that that that
Thanks.
that 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 is if the case, if the challenge isn't coming from somewhere else. Like sometimes maybe the challenge could be the forming tool isn't optimized, but typically it's just the feeder.
Right. Understood. Thank you for that explanation, Andrew. Coming to the next question. In case of oral contraceptive pills, will Cipro feeders work with different tablet dimensions?
Yes. Yeah, correct. Yeah, no, uh, we've done those types of we've done them with Cypro solutions, with tube solutions. We've done them with standard feeding solutions that are the current standard. If it's a vibratory feeder from EMA or Ramaco with the bowl style feeder, yeah. So we've done a lot of oral contraceptives with different types of feeding solutions with different dimensions of tablets, different ways of presenting them to the blister. Yeah, it's a lot of different solutions.
Okay. Now coming to the next question. What's the tablet tolerance range for Cipro feeder and what's the changeover and cleaning time?
Okay, so on so the Cypro, it's forgiving. It's forgiving in terms of the tablet thickness range. So it's not possible to say, exactly. It depends on the tablet shape, but for sure it's going to be more than like a standard vibratory feeder, which is just like it's got a standard lane size, unless it's like the adjustable feeder that I showed earlier that you can adjust it, because with the Cypro feeder, you can adjust how far the stopper pins go in and out. So this lets you try and feed a bigger range of tablet thickness tolerances. And then in terms of the changeover, it's a toolless changeover. So you lift up the cover of the Cypro, you loosen off one knob basically. You lift the feeder system up and off the machine, and then if you have another product with a new change part, you bring the cartridge on, you put the cartridge on, you turn the knob, and you go to the HMI, and then you select the next product that you want to run, and it will go to all the settings for that next product that have been last run, basically the most optimized settings for that product. So there's no operators with maybe trying to adjust the height off the web with the standard feeders. You can have a lot of setup issues with operators. Maybe there's some very good operators that can set up a vibratory feeder very quick, or maybe there's some operators that have challenges in terms of setting up the feeder systems, maybe especially if they're more difficult shaped tablets. So it's a very quick it's a very quick setup in terms of changing from one Cypro feeder to another. Um, and then obviously the cleaning aspect of it, that there's obviously more parts in like a tube style feeder to clean. So the cleaning process once it's outside of the packaging room would be slightly longer than it would be for a standard vibratory feeder, for example, because there's more parts. There's all the tubes, there's the hopper, and there's the fill shoes, basically.
Yeah, great, Andrew. Next question is that can Prodico offer customized null profile?
Yes, we can. Yeah. So yeah, so we've done all the different types of range of neural profiles. So from positive knurls on intermittent sealing to inverse knurl on platen sealing machines to the rotary sealing dies, which will at times can either have positive or inverse knurl, and then different types of pitch knurl, like 0.4, 0.6, 0.8, and then with different distances as well between the pitch heights and the tolerances on the knurl profile. So yeah, there's a lot of different solutions, but typically there's three very common ones, which are either 0.4, 0.6, or 0.8, with with the squares being 0.14 on the length and the width of the square. So yeah, we've very specialized surface grinders for doing the neural profiles that we do. We did a big study into what's the most optimized sealing and why change the different types of sealing designs depending on the pack design.
Okay, okay, understood, Andrew. So we have another question from Prasad sir that do you have any change parts for cold form blisters as well that we are covering in this session maybe, or maybe we can send over some more information on cold form
Yeah, so
blisters later on.
so we make, so this presentation was more in terms of feeding solutions and optimized blister design. But yeah, we make a lot of value formats, a lot of PVC formats, thermoform formats, Aclar formats. We make formats for new materials that are not even on the market yet, so sustainable materials. So a lot of the big material providers will use the Prodico Tech Lab facility, and a lot of the pharma companies are actually using our Tech Lab facility. So there's new innovations in terms of packaging materials, so for sustainability drives. And these materials are not on the market yet, but we're learning how to design the tools and run the tools for these types of new materials that will come in the near future. But for alu, yeah, we make I don't know, thousands of formats per year, maybe alu, I would say. Like
Okay,
there's
great.
there's 260 people in the company. We only make format size parts, so we make a lot of them basically.
Okay, thank you, Andrew, for that answer. Coming to the next question, can you please update more about the multi-feeding tablets and capsule system?
Just repeat that, sorry, Sema, again, sorry.
Yeah, can you please update more on the multi-feeding tablets and capsule system? I think,
Okay. Okay, so in terms of feeding, again, I can pass on more information afterwards, okay, just to make sure I'm
yeah,
exactly answering the question that's required. So in terms of multi blisters, this I'm taking it as multiple different products in the same blister. So like two different types of tablets in the same blister, three, four. I think we've gone up as far as five different colors in the one blister, I think. So we've done different types of solutions. One in a country, I won't say the name of the country, where they're feeding five different color tablets through the one vibratory feeding system. So if you can see my mouse here, we had to split the, sorry, on the solution, I think actually we made three hoppers, and then it came down, and then the conveyor system was split. It was one conveyor system split into five, and then the bowl here was split into five sections to try and keep the products separate. And, and the channel feeder was split into five. So to keep the products completely separate, this was the solution one company wanted basically for an oral contraceptive, which was quite a challenge to try and fit all of that into one feeder system. Some other companies, you will see that they've got the blister machine probably already pre-ordered, that it's extended, and it can take, maybe some companies have four feeding solutions on the line, so a dedicated feeder for each product. In
Yep.
terms of the tube style feeder, there's the ability to put two feeders side by side, and separate and segregate the hoppers basically to feed four or even five different colors. So it depends how many different types of colors or different types of products you want to feed. It will also depend on the arrangement. What does the design of the blister look like? And then there's also the around the budget of the feeder system. So the one that I explained, where I'm not going to mention the country, they obviously wanted a budget solution, um, and that's what we did in that case scenario. In other types of scenarios, it will be multiple, maybe even a dedicated feeder for each tablet, or maybe it's one feeder doing two tablets, and maybe there's two of those types of feeding systems. So it will depend on the machine, depend on the what's pre-equipped on the machine in terms of feeding solutions that's already there. Is it possible to
Right.
do it with the existing feeding system, or does it need something more specialized?
Right. So, Dinesha sir, I think that answers your question, and obviously we'll be sharing more information on mail, and I'll be contacting you after the session as well. So next question, Andrew, is that what kind of precautions are you taking to overcome sealing challenges in flat sealing machines where base film is cold form and lidding foil is CR foil? Should I
Okay,
repeat
so
that for you?
so on that type of scenario, I need to check, but I think on that type of scenario, we're doing a lot of what we would call inverse knurl on the platen seal tool. So this is a platen sealing machine. So platen forming, platen sealing. Typically typically you will see on the market for this solution, for those materials that were mentioned, that there will be a positive knurl on both the upper and lower tool. And what we do in a lot of those situations is we put an inverse knurl. So something like you would see on a rotary sealing machine, which has got the inverse knurl, which is chemically etched into the tool. So it's not machined on, it's chemically etched. So it's the reverse of the positive knurl. We will put this solution onto the sealing dies. We will also change the material for the upper sealing tool. So the lower sealing tool and the upper seal tool will be made of two different materials, because it impacts on the heat distribution basically. And then what we do as a check, because we have blister machines in Berdico, we put the sealing dies on the blister machines in Berdico with the materials, and we run it in Berdico. And then we do blue dye testing. So we do seal check for all factory acceptance tests to make sure that the blisters are sealed correctly before they leave Berdico.
Okay. So should we answer more questions at the end of the session? Is that okay? Or you want to answer it right now?
I don't mind, Seema, whatever you prefer. I'm flexible.
Okay, great. So next question is that from Shekhar sir, they have oval and caplet shaped tablets having almost same dimensions for width and thickness. And for these type of tablets, do you have any solution to feed tablets uniformly in one direction? That is only in thickness wise.
Yeah. So there's different types of solutions. Yeah. So you can orientate depending on the feeder that's on the machine. Okay, so it depends on the feeder system that's on the machine. You can orientate the tablets to feed on their belly band, and you can have the tablets coming down. If it's a vertical chute, you can have the tablets coming down on the vertical chute. If it's an oblong and an oval, and they're similar length, and they're similar thickness, and maybe just a height change, there's the potential to feed them in the same feeder system by bringing them down on the belly band. And then sometimes what you have to do is after this, you may need to knock them over with a brush before they go into the ceiling, before they go into the before they're sealed basically. Or and another solution that we did, which was again, well, it was for a UK customer, but they were sending the products to Japan. They had to they weren't allowed to use a brush on the machine basically. There was no web cleaning brush allowed or no brush allowed whatsoever. So and we had to come up with a feeding solution to feed the tablets to come out flat basically of the feeding system. And the challenge with getting the tablets to come out flat was that the thickness of the tablet and the width of the tablet were almost identical. So, or sorry, not identical. They were within a tolerance of zero point 0.6 of each other. And this creates a challenge in terms that the tablet can enter the feeder in two different orientations. It can enter on its thickness and it can enter on its width of the tablet. And what we did with this feeding solution is we allowed the tablets from the bowl. So from a bowl like this, for example, we allowed the tablets to enter the vertical chute in both orientations. And then what we did halfway down the feeder system is we put in twisting tubes. So we 3D machine twisting tubes, and it would orientate the tablet in the tubes, from its width dimension to its height dimension. So the tablets would come out flat into the pocket without the need for a brush. So in the middle of the feeder, there was kind of like a twisting device to orientate the tablets in one direction only, to ensure that when they arrived in the formed cavities, they came out flat only. So again, it's hard to explain without the image. I could send an image of how we do that or how we've done it, if that answers the question.
Yeah. So Ikar sir, we'll share more information on you through to you on mail, and we can also share some case studies and images so that you have a better understanding of what solution we can provide here. Okay. So coming to the next question, Andrew, Prasad sir they have rotary sealing machine. Can you design a change part which can have effective forming of aclar blisters?
Yeah, so the challenge with Aclar, yeah, so I'm not sure if we've ever done Aclar and rotary forming or rotary sealing, to be honest. I would need to check. I know we've done rotary forming and rotary sealing in the past, but maybe it was for PVC or PVDC. Not sure about Aclar. But in terms of Ackler, I presume it's the same principles that apply. So it's very important how the blister is designed. What's the radius? What's the draft angle? And then that that's one of the key things is the design of the format, and then the same with the same level of importance is the setup. It's the dwell time, the heating, the how long the material is under the heating plates, and the setup for this. So there's a particular type of setup that needs to be optimized to run Aclar. So I think I presume if you get the setup correct and you have the tooling optimized for Aclar, I think you should have a good success, or a very high probability that it should run well on rotary forming and rotary sealing machine. And
Okay.
in terms of like if there's setup parameters that are required or information around what are those setup parameters, it's something we could send on later as well, in terms of
Yeah.
like for normal blister machines. But I think the same concept will apply for the rotary forming and rotary sealing. I think it should.
Okay. Great. So Prasad sir, we can discuss more in detail later on, and we also let you know after checking that we have done provided such solutions earlier or not. So coming to the next question, Andrew, do you have any product recovery system for blisters?
No, it's actually something we were looking at. Well, in terms of recovery system, I'm not sure if that's meant like if that's meant by tablet recovery in terms of deep blister machine, I'm not sure if that's the question. If it is, no, we don't have our own solution in terms of deblistering rejected blisters to recover the tablets. If it's a tablet recovery system in terms of, or sorry, a blister recovery system on the machine, it's something actually we're looking at in the R&D department to see if there's a cleverer way that you don't have to deblister basically. So, um, so in order to reuse the tablets before they have to be deblistered or taken off the packaging machine is something that we're looking at from an R&D perspective. So blister recovery system at the moment, no solution at the moment in terms of if it's actually deblister. No, we don't produce any deblister systems.
Okay, so Rajiv sir, it's something under development at Prodaico, so maybe soon we can come up with a solution like this. So, Andrew, I think that's all the questions for now. Maybe we can just continue with the presentation, and I request everyone to keep the questions coming in the chat box. Thank you, and we'll get back to you at the end of the webinar.
Okay, so maybe just to wrap up on the feeding solutions, I don't think there's any company in the world that would feed the volume of tablets that Verdico feeds or has experience of. So I think if there's solutions, or if there's queries, or if there's challenges, or you would like some information, I would recommend if you wish to send it in, and then we can review it and provide more information basically if required. Um, so. In terms of then innovative blister design and optimization best practice, so we're getting a lot of requests, or have been getting a lot of requests, maybe started about 4 or 5 years ago, in terms of standardization. Pharmaceutical companies were looking to standardize their blister sizes, their carton sizes, which we've got very good experience of doing at a local level and also at a global level. But also more now, I think, in terms of optimizing designs for new materials. So some materials which are actually on the market at the moment, and some materials which are under development and will make their way to the market for more sustainable materials. So we've a lot of work done around that basically, and again we've a large data bank of blister designs across, because we get to make for all the different OEMs. It's a huge data bank of blister designs that we have. We also engage with the material providers, like I said, so the big material providers, Amcor, Constantia, they're probably names that you're aware of, and KP. They typically will use the Verdico facility, so the tech lab facility where we've got all the blister machines, and they'll ask us to produce the tooling for these new materials, and they'll come over and they'll run it on Ullman machines and EMA machines and rotary sealing machines and platen sealing machines in order to try and optimize these new materials. So in terms of blister rationalization at a global level, and we've done a good few projects like this. So typically we get an Excel sheet from a customer with all their tablets, the sizes of the tablets, the current blister size, tablet drawings. The first aspect of our job that we typically do is we group them into their different types of tablet shapes, is step number one. Step number two that we do is that we then design the cavity for the tablets. So in this situation, we're trying to fit as many round flat tablets, for example, into the same cavity as possible. And this also depends on the packaging machine, and you have to consider that in this example, this company had intermittent sealing machines, they platen sealing machines, they had a range of different types of OEMs. So we to consider their complete group of machines and come up with pockets and a concept that would not impact the output speed of the packaging line. So again, it's very critical how you design the cavity to maximize the speed of the machine. In this example, the company was operating with 17 different blister sizes. Now we made a recommendation of to go with 4 sizes. In actual fact, they went with 6 in the end. But this was across their global network, which had like a large number of packaging machines that had to be considered, different makes, different models, different SKUs at different facilities as well. So what we did is we came up with a concept, and we gave them the material utilization rates. We gave them the feeder output speeds. We gave them the changeover times for the different machines. We gave them the tooling cost of the different formats for the different machines. And then ultimately what we did is we just submitted back a project to them and presented to them. And this project is complete over the last couple of years, basically. And then we get a lot of challenges, individual challenges for companies. So they want to either fit more tablets onto the same blister size, or they want to fit maybe a bigger tablet onto an existing blister size. So they, for example, a company might develop a new tablet, and if you go, for example, on an alu cavity, sometimes the cavity can be extremely large and maybe it won't fit, a new tablet won't fit the existing size. So we get a lot of requests about, for example, even on alu, for example, of can you reduce the cavity size? Can you reduce the angles? Can you reduce the material that is required for a tablet? So an example, the original one was 71.5 millimeters wide by 98, and there was 12 tablets in the blister. The challenge for us was to come up with the same tablet, the exact same dimensions of tablets, and try to fit 15 tablets in the blister. So that's what they wanted to do to try and increase the utilization of the machine and reduce the number of blisters in the carton, basically. So came up with a solution. The top solution was not ours, it was from an OEM, basically, and we came up with the solution below. And what we do in this type of scenario is we produce the tooling on a machine in Berdico. So we'll produce the form tool. We'll make sure that there's no micro holes or there's no pinholes issues with the level that we're stretching the material to. But we're finding out that you can push the boundaries more on the alu cavity. Um, it's possible to fit more tablets in, and it's better to utilize the material better. And this was a project we did for one global pharmaceutical company. So we did it for one site on one machine as a test project, and since then we've been optimizing blisters for them at a global level, basically, because it's been successful. This is a similar challenge that we did, basically. So this one's even more aggressive in that there was 14 tablets on the blister, which was the original blister, and they asked us, could we put 21 tablets on the blister? So the same blister size, again, the same blister, and they challenged us to put 21 tablets in the blister. And what this actually having an impact, they could then fit more tablets in more blisters on the index of the packaging machine. So all of a sudden, the utilization of the packaging machine increased, and the cartoning speed increased as well, because the stock height of the number of blisters going into the carton was reduced. And again, we would have made, because we're pushing the boundaries of the alu, we're making tooling in Berdico to make sure that these types of designs work. And what we're doing is we're the design is around the gripping, how you grip the aluminium foil in the forming tool. Um, the specific type of pin, the cold form pin, the material that we use for the forming process is non-standard, basically. So different types of solutions around that. And we're also doing a lot of solutions, like I mentioned, around more sustainable materials, working with different pharma companies and the material providers around more sustainable materials, and trying to increase the efficiency of machines, basically by looking at the blister design, and seeing what can be done from an efficiency standpoint, basically. So I think it's a challenge for the whole industry, basically for every industry, I think, to reduce or to increase the material utilization, basically. So we've got some information around that subject as well, which may be interesting. And that's the presentation. I'm not sure if there's any more questions. If there is, no problem to answer them. Seema, hello.
That count.
You're breaking up, Seema. I'm not sure if anyone else can hear you. I can't hear you at the moment. Deval?
Yes.
Okay. Can you hear me okay?
Yeah, I hear you. Okay, I was just with Seema on the call, so I guess her microphone is not working somehow.
Okay. Is there any further questions, or is there any additional questions that I can help answer?
Yeah, give me a second, Andrew.
Okay.
Yeah, so Andrew, we have couple of questions. So give me a second.
Okay, no problem.
So, Andrew, yeah, the first question we have is from Vamsi sir. That is, have you supplied change parts and feeding systems any customers in India till now?
Sorry, Deval, can you repeat that? Sorry, I just didn't quite catch it. Hello?
Yeah, have we provide any change parts or feeding system in India to any of the customers till now? What is the timeline?
Yeah, so yes, we have supplied. Yeah, so we have supplied to the market before. I don't think it's right to say which customers. I don't think that's the right thing to do. Is that okay for the moment? If there's more details
Uh,
required, I can provide it on an individual basis.
what we can do is we can share the details later.
Okay.
The next is, do you support designing of blisters for CR testing for US market?
Yes, we do a lot of it. Yeah. We've done an awful lot of CR testing for US blisters. And we do the
Okay.
testing. We can do the testing in Bradaico. We've done testing in the US. We've been part of groups in terms of how to optimize the design for child resistant senior friendly blisters. So yeah, nearly a lot of the high
Okay.
percentage of the formats we do for the North American market are for that type of project.
Okay. And I guess, yeah, so that's all. So, yeah, one more is okay. There is one from Shekhar sir. That is, we observed hard gelatin capsule filled with sticking to the lid foil in rotary sealing machine. Did you encounter this issue before, and do you have a solution for this?
Just repeat the question again. Sorry, Deval, once
Sorry.
again. Sorry.
So, here, Andrew, they make a hard gelatin capsules
Yes.
with mini tablets, and that stick to the lid foil in the rotary sealing machine.
Okay.
So, have we provided any solution for that, or had we encountered any issues, something like this earlier?
Yeah, so I'm not sure exactly the product, but a couple of it depends on the actual the blister machine and the rotary sealing machine itself. Like, so there's the EMA have a specific design, so I'm presuming it's not an EMA blister machine. Okay. So what we do in that type of scenario is if the product has got the potential maybe to come up in the pocket a little bit, so it's getting very close to the lidding foil. There's a couple of situations in order how to design the form pocket and maybe put in some type of deboss or emboss in the pocket. So when the product is held in the form pocket, there's a feature there's a feature in the pocket to hold the product in position so it cannot slide anymore and it can't go towards the lidding foil. It's a type of solution we did for a couple of customers. I'm not sure if it's exactly the same, so I'd need to see the drawing and understand exactly what the challenge is, but there's a way to potentially, if it's what I'm thinking of, to design the form cavity in such a way it holds the product in a certain position so it can't, if it's indexing on or if it's not fed in exactly the right location, that it will sit in the correct position basically. And then it's also a case of
Okay.
how does it guide into the sealing roller? Maybe something needs to be done in terms of the position of how it's guided into the seal roller. The web is presented into the sealing roller.
Okay. So then there is one more, Andrew, is do you suggest a different design for CR blisters based on F value?
That's I'm not sure, to be honest. I wouldn't be overly technical, to be honest. So I wouldn't know the answer to that question, but I can get it. To be honest, I can get it from the person that would know, is the person doing the designs. I wouldn't be able to answer that question accurately, to be honest. Oh, but I do think there is, to be honest, but I don't know what the difference is, to be honest. It's something I can check after the call, or if there's a question that comes in, we can provide the information.
Sure, sure. Okay. One more query was, is CR testing required for all strengths and all counts, or the worst that is for stringent F value and higher count only? So for an example, let's say F value for 100 mg is F1, 50 mg is F2, 25 mg is F4, and pack size of
Um,
each strength in this case, please suggest if CR test done for 100 mg 10 blister pack will suffice the requirement for other strengths.
So it depends on, it typically depends, I think, mostly on our end customer, what they require from ourselves on the testing purposes. If they're running multiple different formats with multiple different product strengths, and if they want to test the C or SF of the blister, they will usually ask us to do it on a couple of strengths. But so some customers will come and ask us to do the testing on all the strengths, because the feature or the design principles will be the same. In a lot of situations, it will actually be it can be the same tooling that is used. It's just a different tablet going into the formed cavity. So typically, a lot of that is driven off previous designs that we've done, that we know work, and then it can be a customer-driven thing. Sometimes that they'll want us to test everything for all strengths, all presentations. Um, so it can be customer-driven requirement.
Okay. Okay. Uh, so I guess, Andrew, that's all the queries what we have received from the customers.
Okay. And maybe just to wrap up, so apologies if I was talking too quickly. Irish people tend to talk too quickly. Hopefully there was some value in the presentation. I'd recommend if you do have questions, any questions related to tooling, feeding, optimized blister design, or challenges on sealing, or anything, any challenge you have, I would recommend if you want to send it into Berdico, and there's people that are a lot smarter than me and much more technical than me
Right.
that
So
will be
Andrew,
able
what
to
I guess
answer the
we will
question.
do is okay. So Andrew, what I guess we will do is we will get all the queries what we have, and we will revert back to all the users or who has the query along with the answer
Yes.
after checking. That will, I guess, hope we would be able to answer all of them then.
Yeah, I hope so too. Yeah. Okay, well then, just to say thank you very much for everyone for tuning in. Thank you for your time, and thanks very much, and take care and have a nice evening. Ciao.
Thank you,
Bye-bye.
Andrew. Thank you,
Bye-bye.
everyone, for joining the session. Yeah. Bye.
Bye-bye.